Hi everyone, I'm David. Today I'm excited to share our work, Jigsaw, which aims to support designers in prototyping multimodal applications by assembling AI foundation models. This is work with my advisor, Nick Martelaro. Over the past year, we have seen substantial progress in the capabilities of AI foundation models that can perform a variety of tasks off the shelf without any further fine-tuning, such as generating images, video, music, text, 3D objects, segmenting objects, generating depth maps, and much more. Until recently, creating an AI-enabled system required users to curate their own data, train a model, and occasionally modify the model architecture to adapt to their own use cases. These foundation models essentially become input-output systems, simplifying the complexities of working with AI. With powerful plug-and-play capabilities, many designers have begun embracing AI foundation models to enhance their creative workflows. However, we have identified four key challenges. First, designers find it challenging to use foundation models that exist on different platforms and are specialized for different modalities together. For example, a multi-step workflow of generating a tagline, creating an image, removing the background, and enhancing your image resolution. Designers often currently use AI models for one-off tasks or as standalone applications. Second, designers often have limited knowledge of existing AI models and their capabilities. For example, many designers did not know about image generation models that can support beyond text, such as ControlNet, which can also support sketch input. Third, designers struggle with the need to be AI friendly, which includes difficulties in forming effective prompts and selecting optimal parameters. Fourth, while seamless prototyping and iteration are crucial to the design process, designers find prototyping with these models to be slow and complex and involves wrangling with different tools and interfaces, which inhibits opportunities for rapid exploration. To address these challenges, we developed Jigsaw, a prototyping tool that lets designers generate complex creative content by combining multiple AI foundation models. Jigsaw represents AI foundation models as puzzle pieces and allows designers to combine the capabilities of different foundation models simply by assembling compatible puzzle pieces together. Jigsaw color codes puzzle pieces based on their input and output modalities to signal which pieces are compatible with one another. We identified 6 common modalities used in creative work, namely text, image, video, 3D, audio, and sketches, and implemented a catalog of models covering 39 AI capabilities such as text to image, image to 3D, sketch to image, and more. To find a model capability, users can either search in the catalog, which are grouped by modality, or simply describe their task in the semantic search bar. The search returns model pieces with high semantic similarity to the query. For example, they could search for model pieces to describe an image in words, enhance an image, or generate an image based on another image. Users can combine multiple model pieces to build complex workflows. They can also build multiple chains on the canvas and run each chain separately, allowing parallel exploration. The user can select a puzzle piece to view the intermediate input and outputs at that specific piece. This allows the user to observe how the data is transformed at each stage and adjust individual puzzle pieces if needed. There can be instances where the models do not perfectly align, such as situations where intermediate reasoning is required. We leverage language models as these connecting elements between model pieces, and refer to these instances as glue pieces. For example, ideating what sound effects could be added to a silent video of a coffee shop. The user first attaches a model piece capable of conveying the content of a modality in text, for example, video to text. Next, the user attaches the LLM glue piece for language-based reasoning, text to text. Finally, the user attaches a model piece which translates text into the desired modality, for example, text to audio. Users could also use the glue piece to translate a simple text into a prompt, brainstorm ideas, or perform any language-based reasoning. Finally, Jigsaw provides the assembly assistant, which can recommend a chain of puzzle pieces for a user-specified task. The designer would first provide a natural language description of the task, such as add sound effects for an illustration. Jigsaw then asks GPT to use a chain of models, in this example, image to text captioning, glue piece, and text to audio generation to accomplish the task. The user can make further edits to the chain, just like any manually created chain. Let's see a quick demo of Jigsaw in action.
Jigsaw is a visual prototyping tool for people to combine the capabilities of different AI foundation models, represented as puzzle pieces. Jigsaw consists of 4 main components: the catalog panel, the assembly panel, the input and output panels, and the assembly assistant. In the catalog panel, I can browse through AI puzzle pieces, covering a variety of modalities and capabilities. The puzzle pieces are color-coded by their input and output modalities. For example, a text-to-image piece is colored green on the left for text input and blue on the right for image output. I can select the modality tabs to jump to puzzle pieces taking in certain input modalities. Some puzzle pieces can take in 2 inputs. I can hover over puzzle pieces to inspect more information, including their capabilities, typical runtime, and example input and output. Let's start playing around with AI puzzle pieces by dragging some pieces onto the assembly panel. Suppose I'd like to make a poster for my Friday night DJ party. I'll first use a text input. I see that I can connect my puzzle piece with another green puzzle piece, meaning that it accepts text input. Compatible puzzle pieces snap together. On the other hand, incompatible puzzle pieces repel, making it error-proof. Some puzzle pieces have adjustable parameters, and I can hover over the info icons to see hints on how to adjust them. Instead of figuring out the perfect prompt for my image generation AI model, I can use the text glue in translation mode. This helps me automatically translate a piece of text into a great prompt. The text glue also supports ideation mode, which helps brainstorm an idea for a specified topic or perform any custom language-based reasoning. If I am unsure of which puzzle piece can help me accomplish a certain task, I can use semantic search to find relevant puzzle pieces. For example, enhance my poster. Let's use the increase image resolution piece. Now that I have a good chain of puzzle pieces, I can click Run to pass our text input through the chain. After running, I can select each of the puzzle pieces to see the intermediate input and outputs at each stage in the input and output panels. Sometimes I have a creative goal, but I don't know what combinations of pieces to start from. I can use natural language to describe my goal to the assembly assistant. Let's try adding sound effects to my poster. Let's connect this to our chain and run it. In this demo, I made a simple chain to create an audiovisual poster for my DJ party. With Jigsaw, users can use AI puzzle pieces to prototype interior designs, narrated storybooks, music videos, video game characters, and more. The possibilities are endless.
We conducted a study with 10 professional designers to evaluate how Jigsaw can support them. The study included reproducing an interior design workflow shown in the image below, as well as the opportunity to freely explore Jigsaw and create their own workflows. We found that Jigsaw can help designers better discover and utilize AI capabilities, including new AI capabilities that they were previously unaware of. During their sessions, participants experimented with many different AI puzzle pieces, beyond the well-known AI models they were previously familiar with. For example, This designers discovered model puzzle pieces to generate images from doodles, clone voices, and generate audio effects to create an audio-visual story. In addition, Jigsaw helped support more intuitive prototyping with AI models. Participants liked how they could intuitively see which puzzle pieces can be connected at a glance, and found Jigsaw easy to pick up and start designing with. In addition, being able to inspect the input and outputs of each puzzle piece allowed them to debug individual steps if needed. Finally, designers found Jigsaw useful as a brainstorming and documentation canvas, including documenting the evolution of their design ideas and serving as a boundary object to communicate their ideas to clients. In addition, they found the assembly assistant helpful in combating the blank canvas syndrome by suggesting an initial chain of puzzle pieces to start working with. We observed some interesting behaviors in designer usages of the canvas. For example, this designer kept a separate shoulder chain for rapidly generating different concepts before diving into a more complex workflow. This designer also used the assembly assistant to help come up with a control net workflow to first specify a pose with a wooden mannequin and then control a video game character with the specified pose. For future work, we are interested in expanding the model catalog with multiple alternative models per AI capability and include information on the trade-offs, such as speed versus quality. In addition, we would like to allow users to define their own custom model pieces and support more advanced logic operators for combining pieces, such as if-else and loop statements. Thank you for listening, and to find out more, I invite you to read our paper. Please visit our project page at jigsaw.to.